Hi, my name is Olivia Riley, and today I'm going to be talking to you guys about the structure of the atom and some of the models of the atom and what each part of the atom is. Hopefully, by the end of this video, you will be able to understand everything about the atomic structure of the atom and all of the things inside of the atom. So, to start off, I'm going to define what an atom is. An atom is the smallest unit of matter that anything can be broken up into, and it's compiled of three different things. The three different things are the protons, neutrons, and electrons. Atoms are very, very, very small. They're tiny, and unless you have certain microscope and technology, you won't be able to see them. So even if you have a trained eye or something like that, you will not be able to see an atom because they're just too small. So protons and neutrons are two of the things that make up an atom, and they make up the mass of the atom. So the electrons make up the volume of the atom, and then the protons and the neutrons make up the mass. The protons and the neutrons are inside of the nucleus of an atom, and the nucleus is a small, dense area in the center of the atom, and it has a positive charge. So the nucleus has a positive charge. Basically, what it is it's the center of the atom, and it pulls all of the electrons in, and it holds everything together. The protons inside of the nucleus are positive, and they have a mass of 1 AMU. The neutrons are also in the nucleus, but they don't have a charge, so they're neutral, and they also have a mass of 1 AMU, and the forces holding the protons and neutrons together are called the nuclear force. They are important to holding atoms together in bonds, holding the electrons in, and allowing for the chemical processes to happen. Next up is the electron cloud. The electron cloud is where the electrons are located in the atom, and while electrons don't have a set spot where they can be found, so you can't just tell someone that it's going to be found right there every single time, there's a probability to where they can be found, but they will really never be in the same spot every single time. So they orbit the nucleus in shells or orbitals, and there are four. The four are S, P, D, and F. Each has a different energy level and different amounts of orbitals. So S has 1, P has 3, D has 5, and F has 7. Each one can hold 2 electrons, and the more orbitals you have, the higher your energy level gets. So the energy levels are basically how far the electrons are from the nucleus and the farther away you go. So the farther away you go, the smaller the jump is. So let's say this is the center or whatever. This is the jump at first, and then this is the jump, and then it just keeps getting smaller. So it doesn't get bigger, it gets smaller. And so that means that the first energy level, like this, is going to be large, and then they keep getting smaller. So the energy levels keep getting smaller. The electron cloud is not dense, though, because electrons don't have mass, but they do make up a large part of the volume of the atom because how far away they are from the nucleus in comparison to the size of the atom. Atoms aren't only made up of protons, neutrons, and electrons, but the ratios of protons, neutrons, and electrons make up the atomic number, the isotopes of different elements, and they're pretty much like the identity of each element, and each element is different. So none of them are the same. They might have similar properties, but none of them are exactly the same. The atomic number is the number of protons in an atom, and it basically determines what kind of atom that is. If the number of protons change in an atom, then the atom will change its chemical properties and chemical identity. So pretty much what that means is it's going to be a different element. You can't have a completely different number and it be the same element. It's going to be probably a different one, or maybe combination, but it won't be the same one. They are all different. And even if let's say you have 2 Fe's, two irons, they might be a little different. Isotopes are when an element has different mass numbers, and that is only changed by the number of neutrons in the nucleus, and different isotopes can be stable or not stable. It's based on the ratios of each component of the atom, but it all depends on the ratios of everything. So pretty much there have been different models of the atomic structure. I'm going to talk about 3. I'm going to talk about the Bohr model, the plum pudding model, and the current model that we have now. The Bohr model was based around hydrogen, and it's 2D, and it's his version of the atomic structure, with the center being the nucleus, and then they have different orbitals around the nucleus, and those orbitals hold the electrons. The plum pudding model was made by J.J. Thomson, and it's one of the first thoughts of what the atom looked like, and it was overall positive, and it had like electrons like sprinkled in the middle. So I like to think of it as a chocolate chip cookie. So think of like the little chocolate chips as like the little sprinkles or whatever, and that's them sprinkled in there. It didn't like have a nucleus pretty much, and through experimentation and like as we started learning more, we realized that this model was wrong and it was not accurate. The current model, so what we have now, is it has a dense nucleus in the middle and electrons traveling on orbitals around the nucleus. And the probabilities of where the electrons like may or may not be, like we figured all that stuff out, and so we have like a good idea pretty much. Another main thing of atomic structure is that within the electrons is valence electrons. The valence electrons determine the chemical bonding of an atom. So depending on valence electrons, it depends on how many you have if you want to get rid of. So if your electron activity, whether or not you want to get rid of an electron or keep an electron, determines your bonding. So there are different types of bonds like ionic and covalent. And pretty much if you have like the valence electrons determine that kind of bond. So in summary, pretty much, the atom is the smallest unit of matter, and it's made up of protons, neutrons, and electrons. And once again, the atom is very, very, very small. So if I look at something, let's say I'm looking at these glasses, I can't see atoms in them. I'd have to like pull out a special like microscope and look at them, but I cannot see atoms just by looking at it. And then surrounding the nucleus in the atom, in the electric clouds, are negatively charged electrons. They make up the volume of the atom, and they neutralize the charge of the nucleus. There have been many models to show us. The Bohr model, the plum pudding model, and then the current model that we have now. And the compositions and ratios of the atomic structure determine the atomic number in different isotopes of the atom. And an identity and valence electrons are incredibly important. Those are the electrons on the outside of the atom, and those determine bonding, properties, and everything else like that. So that was my video on the atom and the atomic structure and some of the models. So I hope that helped you, and good luck.